Hello, Math 153. Welcome to Unit 4, which is from Chapter 12, and it's all about statistics. What we're starting with in this lesson is 12.1, Sampling, Frequency Distributions, and Graphs. You can take a moment and read the objectives there for what we're looking at in this section. The first thing we're talking about is populations and samples. Go ahead, pause the video, and read the definition of population and sample. Okay, now that you've read those definitions, to kind of put these in terms that might be a little bit easier to understand, think of if there was going to be a survey that was given to all students at Pennsylvania College of Technology. The population would be all the students at PCT. Now the sample is going to be a subset or subgroup. Maybe they're only looking at the women's surveys then, or maybe all the students in the math classes. Those would be what the sample is, because it's just a subset or a portion of that entire population. Okay, example 1, populations and samples. A group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. And the two things we're looking at is A, it says describe the population. So let's go ahead and start with that. So population, we want to know who is going to be the set of all the people or objects. And in this case, the set is going to contain all the citizens of the city. So the population is, we say, the set containing all the citizens of the city. Now, one hotel owner suggests obtaining a sample by surveying all of the people at the 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion on casino gambling. Does this seem like a good idea? What I want you to do, pause the video, reread that again, and you want to determine, does it seem like a good idea to only survey the people at the 6 of the largest nightclubs in the city? The answer is going to be no, meaning this is not going to be a good idea if they want to get a nice, fair survey amongst the people. And why or why not? Well, we're going to say no because maybe the nightclubs are affiliated with the casinos, so the people that are at the nightclubs might be more okay with the gambling. So it's not really going to be a fair assessment of the city as a whole. So we're going to go ahead and write that. So we said no, maybe because the people at a nightclub, we can say they might enjoy gambling. Okay, so we're going to continue with that example in the next one. So what we want to talk about is the idea of random sampling. Is we don't want to just target a certain group if we want to get a survey, whereas we need to look at the group as a whole and really get a fair survey amongst that group or amongst the population. So a random sample is going to be a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. So taking it back to the beginning when I was talking about, if we're talking about Pennsylvania College of Technology, all the students were the population, and maybe we just surveyed the females. That's not going to be a good example of random sampling because we're only targeting a certain group of people. So we need to figure out, okay, you want to figure out a systematic approach where you could definitely pull a randomized subset or sample of that population. So the example 2, okay, going back to example 1 talking about the casinos. We return to the hotel owners in the large city who are interested in how the city's citizens feel about casino gambling. Which of the following would be the most appropriate way to select a sample? So go ahead, pause the video, read through those and figure out, okay, which one would get a nice randomized sampling of all the people in the city. Right, we're going to say choice C, randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. The reason why the other ones don't work out, so part A, or choice A, is randomly survey people who live in the oceanfront condominiums. There you're only targeting one specific group. Maybe the people that live in the oceanfront condominiums, maybe they're wealthy and maybe they have, they don't want to spend their money or gambling, or maybe they have a pastime of being affiliated with a certain casino. So you want to be careful with only choosing from a certain geographical location. Letter B, survey the first 200 people whose names appear in the city's telephone directory. You might think, okay, that sounds randomized, but what about if citizens don't have cell phones? Or what if they don't have a landline phone that's actually going to be in the directory? What if they opted out of being on the directory? So there you're already excluding people from the randomized sample. Choice C is going to be the one that's going to give us the most randomized sample of the population. Okay, moving on. So now what we're going to be doing is talking about what we call a frequency distribution. And what we're going to do is be constructing a frequency distribution. A frequency distribution is a chart, if you will. So the first one, construct a frequency distribution for the data of the age of the maximum yearly growth for 35 boys. So what they did is they pulled 35 boys and we figure out what age are they when they had the most growth. So what we want to do is just look at the data set, and there's a couple ways you can go through it. So I have it a little bit filled in for you by the first age of maximum growth is going to be 10. So what we want to do is look through this list here, and I'm going to actually choose a different color so I can see it as I cross it off a little bit easier. There we go. So what we're going to do, so the first one, age 10, well, you can see that we have 1 10 there, and that looks like it. So we have 1 10-year-old. So we're just going to put a 1 there. Now 11-year-olds, going through the list again, you can see that we have 1, 2 11-year-olds. So I'm going to put a 2 over here. What I want you to do is now take a moment and fill in the rest of this frequency distribution. So count up how many, 12, 13, 14, 15, and so forth, and fill the chart in. And then you can unpause the video and we'll go from there. Okay, you can double check yours with mine. And what we're going to do then is add all these up. So it says at the bottom here in the bottom row, it says total n equals. We want to count up how many numbers we have here. And when you count all them up, you should get the value of n equals 35. When you count up all these values here, if you are not getting 35, then you must have missed something somewhere. We know it should be 35 because that also tells us how many boys there were in the original problem where they told us there was 35 boys. What we say about this number here, we're going to say this is the sum of the frequencies. The sum of the frequencies here is going to be 35. That's the sum of the frequencies. Now, we're going to just kind of define some of these terms in here. The numbers that we have in the left-hand column, the ages here, these numbers right here, these are all going to be what we call the data values. These are going to be the answers, if you will. How old were you when you grew the most? So these are going to be the data values. And we see that the way we can read the columns then is something like, if we look at this, the rows, if you will. If we look at this row specific, we say the data value 11, so we can say the data value of 11, we can say that that occurs 2 times because that's what the 2 represents. Now, the other thing we want to talk about is all of these numbers in the right-hand column. These are what we call the data items. So each piece here is called a data item. So this is called a data item. So we have data values and we have data items. And we said all together we have 35 items. So this is just becoming familiar with these frequency distributions. And that's what we did here is we created a frequency distribution. That's what this chart is considered. So now what we're going to do is we're going to create another kind of frequency distribution. And this is going to be what we call a grouped frequency distribution. The difference here is we're going to be creating groups rather than having all the individual data values like we did in this first one. Here we only had, 2, 4, 6, 8, 9 different data values. Whereas when we look at this group here, we have 40 students and the data values are all over the place, 82, 76, 94, and so forth. So it's not going to make as much sense to list them all out because we just might have a whole bunch of ones in the frequency column. So what we're going to do is create groups here. Now with a lot of the problems, they will tell you how to create those groups. They'll tell you what to use. But for now, we want to figure out how, if we wanted to create the groups, what would we use here? So when we look at this list, we'll see that the lowest value here, the lowest value is 43. The highest value here is 94. So we want to create groups that involve all the values between 43 and 94. And what we're going to do, and I'll kind of get you started with this one, we're going to take our first group and make it all these are talking about test scores of students. We're going to say the first group is going to be all the scores between 40 and 49. And then the next group would have to be 50 through 59. The idea is you want to keep the same increments between each of these. So you can see how I'm numbering them. Go ahead and do the same thing on your paper. Now, within all these groups, all of these values will be in this list. Then we can also identify some of the numbers here. The number on the left-hand side, the 40, 50, 67, this is going to be called what we call a lower class limit. Lower, see if I can squeeze this in here. This is what we call the lower class limit. The number on the right, as you may have guessed, is called the upper class limit. This is the upper class limit. That tells us the highest and the lowest score within each group. So now I included a column for the tally marks here. This is just going to be a working column, if you will. This is just where we're going to keep all our tally marks, and then in the third column is where we're going to create our findings. So what I want you to do is go through this list and create your tallies. So for example, the first one we have here is going to be 82. So that would be a tally in the 80 to 89. 76 would be between 70 and 79. And you can see that I marked them off as I went, that way I didn't forget anything. So go ahead, pause the video, and go ahead and create your tally portion of this. Okay, now that we have all our tally marks, what we can do now is add them all up. So in the first group, 40 to 49, we see that 3 students had a score in that group. We see 6 students had between a 50 and a 59. 6 students had between 60 and 69. 11 between 70 and 79, 9 of them between 80 and 89, and then 5 of them had something between 90 and 99. So this would be helpful for a teacher because they could then see where does the most of the class lie. You can see that 11 got a C on this exam, if you will. So that tells you that's where the bulk of it is. And then they can see somewhere below, somewhere above, and they can just see how the students are grouped together. Now, another vocab word you need to know is what we call class width. Class width. And what this does, this tells us how big each of our classes are. We're going to say the class width here is going to be 10. And how you find this is it's going to be the difference between any 2 consecutive lower class limits. So the class width is found by taking the difference between any 2, we have to say consecutive, meaning they're next to each other, any 2 consecutive lower class limits. So for example, let's just choose 2. Let's say 60 and 70. If we were to find the difference between those, so 70 minus 60 equals 10. That's how we know that the class width would be 10. So on some assignments, it might say create your class width to be 10, create the class width to be 5, and that tells you how to set up your classes here. Okay, moving on. A couple slides ago from 40 to 49, we knew that there was 3 because this class width here was the next page. So what we can then do is take the frequency frequency distributions that we created, and then we can create some bar graphs from them, and we're going to call them histograms. So we're going to call these a histogram. So the first one is we have a frequency distribution. This is one that we created on the first page. What we can then do is take that to create the histogram, which is what we see in the second picture. This is what we call a histogram. Very similar to the bar graph that you might be familiar to. And what we're doing is taking each data item or each data value and creating the bar graph that associates with how many items there are. So for example, the maximum age growth of 10, we had 1 boy. So at age of 10, we had 1. Age 11, we had 2. Age of 12, we had 5, and so forth. So we're using these as, if you will, the X and the Y values to create these graphs here. So then what we can do is take the histogram and then create what we're going to call a histogram with a superimposed frequency polygon. And we're going to draw this in here. So whenever you see the terms a superimposed frequency polygon, what we're going to do is we're going to plot points, if you will, at each of these bars. At the top of them, like I'm doing here. And then from that, what we're doing is going to be connecting all of the dots here. So we're just going to be connecting them as best as you can. I know it might be hard with if you have a ruler or something, it does make it a little bit easier to draw straight lines. If not, just do your best. Kind of hard for me to do this on the iPad, but we'll see how we get. And you want to go for every 2 dots. Don't try to connect them all into one line. Even though it might look like they can connect that way, we want to avoid doing it like that. And you can see this one would be more. And then we can just kind of end this one down here. And like that. So what we created there is this superimposed frequency polygon. Now, in the last box that we have here, we want to create what we call the frequency polygon. So keep in mind the difference is only this word superimposed. Superimposed is when you lay that frequency polygon over top of your bar graph. What we're going to do with the frequency polygon is take the lines that we just drew here and only bring them over into the frequency polygon. So what you want to do first is plot all your points. For example, at the point 10, 1, plot a point. 11, 2, 12, 5, and you want to plot all those points over here. So go ahead and do that. I'm going to pause the video and fill in mine while you do the same. Okay, you can see I have all my points plotted, and you'll see that it should have the similar shape as the one we just created. Now what we're going to do is just draw in our straight lines like we did before. Now, a lot of times since we're going from 0 to 10 in this first increment right here, and all the rest of them we only count up by ones, we can create a little point of our graph. It looks like a little jagged. You may have seen this before, and that just means there's a break in the graph, that the scaling isn't the same. And from there, we're going to connect all of our dots. Again, you want to make sure you're going from dot to dot and not try to just create one line that connects everything. Oops, that last one turned out a little bit crooked. Okay, so there we have the frequency polygon. So make sure you're familiar with all the different kinds that we have. Again, this first one is the frequency distribution. The second one is the histogram. The third one is the superimposed frequency polygon. And the last one's going to be the frequency polygon. This is also frequency polygons, very considered a line graph, and a lot of you have seen that before. Okay, the last page. Do that. Another kind of graph we're looking at is what we call a stem and leaf plot. This is just another way to present the data. And depending on what kind of study you're doing, might depend on how you want to display the data. One way might be better fit than another way. So what we're going to do is create what we call the stem and leaf plot. The stems, you're going to think of these as the numbers in the tens place, if you will. So for example, the 8 would be a stem, the 7, the 9, the 7, the 5, and so forth. And this is going to be the same group of data that we looked at in the previous example with the grades or the exam scores. So we know from before that the low grade was a 43 and the high grade here, the high grade was a 94. That tells us that the smallest stem we need would be 4 and the highest stem we need would be 9. And we can see that 5, 6, 7, 8, 9. You want to make sure you do not skip any and you fill them all in. Now what we're going to be doing is filling in the leaves. And this is where the number that's in the ones place of each of these data items becomes important. So for example, I'm going to use a different color here. So for the first one, we have 82. So we go to the stem of 8 and we put a 2 is a leaf. The next one we have 76. Go to 7, add a 6. 94, go to the 9, add a 4. Next one is 75. So we're going to go back to the stem of 7 and now we just add a 5. We don't use any commas or anything, just leave a little space and put your 5. The next one we have is 57. So we put that number there. So go ahead, pause the video and fill in the rest of your leaves. Here you can see we have all of our leaves filled in. Now if you go to count these, you can see that you have 3 leaves for the stem of 4. So that means there's 3 data values in this group here, if you will, which we also is our stem of 4. And you could go ahead and count up all of these items, if you will, and you notice that we would get 40 there. Okay, the last little quick example we want to look at is deceptions in visual displays of data. And this is something that you might have noticed on the news, if you watch the news, that sometimes the graphs they want to try to portray one idea, but they're making the graph look, they're trying to make it look accurate, but it's really inaccurate, which is giving us a false thought. So kind of an example of that here. Graphs are often used to distort the underlying data, making it difficult for the viewer to learn the truth. And they do this to not really trick the viewer, but to give off a different view, if you will. So looking at this picture here, it says the Small Business Administration reports new business survival rates. They say 70% of new businesses survive 2 years, 51% of new businesses survive 5 years, and 30% of new businesses survive 10 years. So there's a couple inaccuracies with this. One thing you might notice right off the bat is they're giving us the percentages of 30, 51, and 70. Well, if we add 30% plus 51% plus 70%, they do not equal 100%. So right away we know this pie chart is inaccurate because it adds up to way over 100%. Another thing, kind of in the same idea, you'll notice that the shading is not accurate. We know that 51% would be a little over half. Well, this yellow shading here does not represent a little over half. So we can say here that this shading is not accurate. So those are just some things. So what I encourage you to do is when you watch the news, if you watch any kind of news that shows any kind of graphs, see if you can pick out any kind of deceptions within the graphs. Okay, that's all we have for 12.1. So good luck on your homework and please reach out if you have any questions. Have a good one. Bye.